Hi everyone, in the video today we're going to take a look at solving a second order differential equation which is homogeneous, which is just a very fancy way of saying the right hand side is zero, it's linear, and we have constant coefficients. So solution. So how do we solve these problems? Well, the solution comes from the auxiliary function. Auxiliary function is a function that helps us to find the answer. The auxiliary function, well, the second derivative we replace with an m. The second derivative with m squared. The first derivative with m. And the solution just a 1. So in our case we have m squared, take away 6m plus 34, that equals 0. Now the solutions of this quadratic are related to the final solution for the differential equation. So let's go ahead and solve it. I think I'm going to complete the square because the coefficient of m is even number. Half of that is minus 3, so this should be quite nice. So if I times this out, I get m squared minus 6m plus 9. I don't want plus 9, I want plus 34. So I have a 9, I want 34, so what do I need to add to it? I need to add 25 more. Okay, that's the way I do it. There's some alternative ways of solving that. This is what works for me. So to find m, I'm going to take the 25 to the other side. So I have something squared is a negative number. It looks like I'm in the territory of complex numbers. So taking square roots, we have the square root of minus 25, which is the same as the square root of minus 1 times 25, which is, I'm going to write that a bit tidier, which is plus or minus the square root of minus 1, which is I, times the square root of 25, which is 5. Okay, so the final answer is 3 plus or minus 5i, and I think I'm going to write this as 3 plus 5i, or plus 3 minus 5i. My two solutions, 3 plus 5i, 3 minus 5i. Okay, so the solution to the differential equation has a certain form which we need to be aware of if we're going to solve this problem. And the form is, well, if the auxiliary equation has solution p plus or minus qi, then the answer is e to the px cos qx times a plus sine qx times b. Okay, so you even need to know this, or if there's some formula sheet, know that you can look it up quite easy. In our case, p is 3 and q is 5. So our final answer is e to the 3x a cos 5x plus b sine 5x. And there you go. This is the solution thing that we were looking for is the solution of our differential equation. And a bit better than that, actually, it's the general solution. So all solutions have this form. It's the general solution of this equation. Okay, so there you go. That's the end of this video, solving this second order differential equation where the auxiliary function had some complex roots.